Back to the point that I was trying to make. If we did have an airless room, then the sound would have no medium to travel on. So you could no longer hear me, but since light is an electromagnetic wave and doesn't need a medium, you could still see me. Here is a typical depiction of an electromagnetic wave. We have the series of perpendicular electric and magnetic fields propagating through space. Being a wave, we can then use things like frequency and wavelength to describe them. This is probably not the first time that you've heard these terms. The visible light that we see, being an electromagnetic wave, is just a small section of what we call the electromagnetic spectrum. This spectrum contains wavelengths and frequencies ranging from the unimaginably tiny to the insanely huge. Although we can't see most of the spectrum, we experience many of these in our day-to-day and not-so-day-to-day lives. Things like the infrared beams we use to tell our televisions what to do, the UV rays that cause sunburns, microwaves that cook our food, radio waves that bring us our music, and X-rays that can see whether or not our bones are broken, as well as gamma rays that we can observe coming from the most massive explosions in our observable universe. While we may experience all these different forms of electromagnetic radiation in different ways, they all have one thing in common: the cosmic speed limit, the speed of light. Given the symbol of c, this speed is about 3 times 10 to the 8 meters per second, or 300 million meters per second, which is pretty fast, but is still finite. From all this, we can now use a wave speed equation to connect wavelength, frequency, and the speed of light. Now you can figure out just how big the radio waves broadcast by your